Hey everyone! Welcome to Algebra 1. Today, we are kicking off Chapter 1, Working with Real Numbers. Here is our roadmap. We have sections 1.1, 1.2, 1.3, and 1.4. But for today, we are going to dive straight into section 1.1, Sets and Expressions. Let's get started. A set is a collection of objects. Each object in the set is called an element or a member. You use the symbol epsilon to show that something is a member of a set. The symbol means the opposite, it is not a member of. Sets are usually named by capital letters. The elements of a set are enclosed in braces. For example, A equals the set containing 1, 3, 5, and 7. The universal set, denoted by the symbol U, is the set of all objects under consideration. So in a math course, the universal set often consists of all numbers. To understand sets, let's imagine a pizza. A pizza is a collection of toppings. Each topping is an element of that pizza. Pepperoni is on the pizza, so it is an element of pizza A. But pineapple is not on this pizza, so it is not an element. We name our pizza with a capital letter, like A. And we list all the toppings inside braces. Pizza A equals pepperoni, olive, and mushroom. Finally, the universal set U is like the entire kitchen menu. It contains all possible food items under consideration, including pizzas, pastas, and drinks. Let's work on a practice problem. Given that set B equals 3, y, 7, and alpha, determine whether each statement is true or false. For A, y is an element of B, so the statement is true. For B, 7 is also an element of B, so it is also true. For C, 3 is an element of B, meaning 3 not in B is false. Finally, for D, 5 is not an element of B, so the statement is false. An empty set, or null set, is a set without any elements or members. It is denoted by the slash symbol or empty braces. A subset is a set whose elements are all contained in another set. The horseshoe symbol means is a subset of. Remember two important rules. Any set is a subset of itself, and the empty set is a subset of any set. To understand the empty set, imagine an empty transparent bag. Because there is absolutely nothing inside it, it represents the empty set. Now, imagine a smaller bag placed entirely inside a larger bag. This small bag is a subset of the big bag, meaning everything in it belongs to the larger one. Think about it. Any bag contains its own items, so it is a subset of itself. And an empty space is always inside any bag, so the empty set is a subset of every set. Let's check our understanding with a practice problem. Given that set C equals 2, A, and 5, determine whether each statement is true or false. For A, the set containing 2 is a subset of C, so it is true. For B, 5 is an element, not a set, so using the subset symbol makes it false. For C, any set is a subset of itself, so it is true. Finally, for D, the empty set is always a subset of any set, so it is also true. In Algebra 1, the sets used are usually subsets of the real numbers. The set of real numbers, denoted by R, consists of all numbers on the number line, including integers, decimals like -1.1 and +1.5. The following are standard subsets of R: natural numbers starting from 1, whole numbers including 0, and integers which include all whole numbers and their negatives. Let's test our understanding with a practice problem. Given the subsets of real numbers, determine whether each of the following statements is true or false. For A, all natural numbers are contained in whole numbers, so it is true. For B, whole numbers only include 0 and positive integers, so -3 and W is false. For C, 1.5 is a decimal and all decimals belong to real numbers, so it is true. Finally, for D, natural numbers start from 1, meaning 0 is not an element, so it is false. A rational number is a number that can be expressed as a fraction p over q, where p is an integer and q is a natural number. For example, 0.25 can be written as 1/4. An irrational number is a number that cannot be expressed in that fractional form. For example, the famous mathematical constant pi is approximately 3.1415, which goes on forever without repeating. Both the set of rational numbers q and irrational numbers I are subsets of the real numbers R. Let's test our skills with a practice problem. Identify whether each statement about rational and irrational numbers is true or false. For A, 0.25 can be written as 1/4, which is a fraction, so it is true. For B, pi is an irrational number because it cannot be written as a fraction, so the statement is false. For C, the square root of 2 is a non-repeating infinite decimal, so it belongs to the irrational set, which is true. Finally, for D, a number cannot be both rational and irrational at the same time, so their intersection is the empty set. This is true. The union of sets A and B, denoted by union V, is the set of all elements in either A or B or both sets. Let's look at an example. Suppose set A equals 2, 5, 7, and 12, and set B equals 5, 7, 10, and 18. Find a union V. Elements are not counted twice. They are either in or out. So 5 and 7, which are in both A and B, only appear once in the union. Therefore, a union V is 2, 5, 7, 10, 12, and 18. To understand a union, let's imagine ordering a half and half pizza with a friend. Set A is your favorite toppings and set B is your friend's toppings. The union is the final pizza containing all requested toppings combined. What if both of you choose olives? The pizza place won't dump a double amount of olives to ruin the pizza. Olives are simply placed on it once. In a union, shared elements only appear once. So, if your toppings are pepperoni and olive, and your friends are olive and mushroom, the total union pizza is simply pepperoni, olive, and mushroom. Let's test our skills with a comprehensive practice set. Given 4 distinct sets, A, B, C, and D, find the union for each of the following questions. For number 1, combining sets A and B and listing them in order gives 0, 1, 3, 4, 5, 7, and 8. For number 2, we list the combined elements from smallest to largest, making sure the shared 6 appears once. For number 3, sets A and C share 3 and 5, so we list them once in order. Finally, for number 4, combining B and D and arranging them from smallest to largest gives 0, 1, 4, 6, and 7. The intersection of sets A and B, denoted by A intersection B, is the set of all elements that are in both set A and set B. Let's look at example 2. Let set A equal 3, 8, 11, and 24, and set B equal 1, 8, and 15. Find A intersection B. Only the number 8 is in both A and B. So, A intersection B equals the set containing 8. To understand an intersection, let's imagine finding a time to hang out with a friend. Set A is the hours you are free, and set B is the hours your friend is free. The intersection is the specific time you can actually meet. If you are free at 3, 8, 11, and 24, and your friend is free at 1, 8, and 15, you cannot meet at 3 or 1. You must pick 8 o'clock because it is the only hour you both share. In math terms, your schedule intersected with your friend's schedule leaves only 8. Therefore, A intersection B equals the set containing 8. Let's check our skills with a practice problem. Given two distinct sets, A and B, find the intersection of the two sets. Looking at both sets, only the numbers 4 and 9 appear in both A and B, listing them from smallest to largest. A intersection B equals the set containing 4 and 9. A numeric expression contains only numbers. Since there are no unknown quantities, you can always work out its exact value. For example, 1.05 times 4 evaluates to exactly 4.2. Numeric expressions with the same value are like different names for the same thing. All these expressions have the exact same value of 4.2. 1.05 times 4, 4 plus 0.2, and 5 minus 0.8. Because they describe the exact same thing, you can always substitute one for another. If you see 1.05 times 4 somewhere, you can write 4 plus 0.2 instead. Let's check our understanding with a practice problem. 3 of the following numeric expressions evaluate to the exact same value. Identify the one that does not belong. Let's calculate each expression. A, B, and C all evaluate to exactly 3.5. They are different names for the same value. However, expression D evaluates to 2.5, which is not equal to 3.5. Therefore, D is the correct answer because it does not have the same value. A lot of the time in math, you can use letters to stand for unknown amounts. For example, if you were not sure how many inches long your desk was, you could just call the length x inches. When you see letters in equations, they are just numbers that you don't know the value of yet. Letters that represent unknown numbers are called variables. To make it easier, think of a variable as a mystery gift box. The letter X is just a label written on the outside of the box. We don't know what number is hidden inside yet. Depending on the situation, the box could hold a 5, a 10, or any other value. Once we solve the math puzzle, the box opens up to reveal its secret number. Let's test our knowledge with a practice problem. Which of the following is an algebraic expression that contains a variable? Let's analyze the options. Expressions A, C, and D contain only numbers and operations, which means they are numeric expressions, not algebraic. However, expression B contains the letter x, which is a variable representing an unknown number. Therefore, B is an algebraic expression and is the correct answer. A coefficient is a number that multiplies a variable. In the algebraic expression 3x, the number 3 is the coefficient of x. Think of the variable x as a single mystery box containing candies. If you have 3x, it simply means you have 3 identical mystery boxes. The coefficient tells you the count of the boxes. If each mystery box holds 5 candies, 3 times 5 gives you 15 candies in total. The coefficient multiplied the value inside. Let's check our understanding with a quick practice problem. In the algebraic expression, negative 5x plus 7, identify the coefficient of x. Remember, a coefficient is the number that multiplies a variable. Here, the number multiplying x is negative 5, not just 5. The negative sign stays with the coefficient. Therefore, the coefficient of x is negative 5.